I don't know, fortunately or unfortunately, this time I have got the topics which are very, very easy for a teacher. And I think all of you must have some time taught these topics. So rather than just taking lecture, let's make it interactive session. Because these things you already do at your B.Sc first year level itself. The purpose of keeping this experiment is to show that with a very simple 2-3 apparatus, you can design many things. Basically, this course is designed for that only, that with the low cost, we can do number of experiments. That's a base or starting point for these experiments. So this also, though the experiment is easy, all which 3 experiments I have to take on AC, the AC circuits, AC bridge and AC filters. So these things you are already doing it, being teacher. So let's make it interactive and discuss the things. Wherever you get the difficulty, I get the difficulty, let's talk about those things. So I will start today with the first topic, that is AC circuit and resonance. Now what do you mean by AC? Alternating current, where you have current or voltage changing sinusoidally. Now when it is changing sinusoidally, I don't have a constant value like DC. So there should be something which I should use for calculating power, or when I measure, what do I measure, and so on. So for that, you know what we do. With the meter we measure it, and it is the RMS value. So when I do a derivation, at the end I am going to substitute the measured value. Therefore, what I do calculations and all that, in that I must substitute the RMS values. So my formulas should be going in that. Now, what is the major difference when I take AC rather than DC and go for components like resistance, capacitor and inductor? What will be the main shift? So there will be a phase shift of between current and voltage. Now what we mean by phase shift? It's very easy to talk, but it's difficult to explain students what I mean by phase shift.
That means once are not happening at the same time.
Either one is lagging behind or the second one.
That means if I increase the voltage, I did not see the current increasing or decreasing in the same way. So if I have a voltage, it may go first to peak value, then the current. So we say it leads, but vice versa. When there is a phase, then phase shift, then what happens to the resistance offered? Rather than resistance, we have what is called impedance. So the impedance has actually 2 parts. One where phase is 0, that is my resistive part, and one where I have phase, which depends on the component like L, C values and so on. So that is called reactance. Capacitive, or maybe if I have both together, total, it is reactance. So what is the difference between reactance and the resistance?
Reactance is a function of frequency and resistance is the fixed frequency.
That is one which is dependent on the frequency, that is reactance. Now depending on L or C, my reactance will be different. And if I take number of components, it will be still depending on what I have, I will get the reactance. 0, taking components in that way or choosing proper frequency, I can get resonance in the search. So now let me start with so we define AC, where you have current sinusoidal, and we have E equal to Vp sin omega t minus the phase, which is phase voltage or phase difference, phase for voltage and phase for current. So I will get IB minus phi B minus phi I